let's just do this question, which is basically they are saying that an unbiased coin is tossed. This is unbiased coin, which means it is a fair coin, repeatedly until the outcome of two successive tosses is same. Which means they are saying either head appears or tail appears. It is not like that only head they are focusing or only tail they are focusing. Okay, they are saying if either head appears or tail appears, they are fine. So for that, how many expected number of processes are needed? Let's just see this. See, you will start with nothing. Either head will come or tail will come. Then obviously you will do one more time. Either head will come or tail. Right? Now earlier we restarted here because we wanted head. Now tell me, can I restart here? Just think about it. Can I restart here? Obviously no, right? Obviously no. Because you have already made one progress of tail because you are looking for tail also. So that's why you cannot restart here. That's the problem here, right? Okay. So earlier, I mean, this was the earlier, let me just write it. This was the earlier where I said that I can restart here. Earlier means you're looking for head. Okay. I said I can restart here. Maybe I can stop here. I can restart here. So earlier was quite easy, but now this question is actually tricky. I mean, tricky in the sense that I cannot actually restart at the desired point or I cannot stop at the desired point. Okay. So that's why this question is little tricky. Let's just try solving it. So what we have, we start with nothing. We will either be getting head or we will be getting tail. Okay. So I cannot restart here and I have to explore this. I have to explore this also. That's interesting. I mean, we can do it, but I mean, we can actually explore to multiple trees, multiple branches. That's okay, multiple levels. But let me just say that till now I made one toss, and let me just say that in future, see, E. Let's suppose E is the answer for this question. E is the answer. Okay. Let's just say that in future I will be needing even tosses here. Okay, and here I have already made one toss. Let's suppose in future I will be needing E2 tosses. Suppose if I just draw the tree like this, and if I try to convince you that we will be needing, let's whatever we will be needing, I'm just calling it E1 and E2. And since this is a fair coin, so that's why it is 1 by 2, 1 by 2. So the final answer will be E, which is 1 by 2 into 1 plus E1 plus 1 by 2 into 1 plus E2. Even and E2 some numbers, okay, that we are yet to calculate. I mean, one I already made, and then in future, let's suppose E1 I will be needing. And one I already made, in future, let's suppose E2 I will be needing. These are some numbers that I yet to calculate. So let me write the description for E1 and E2. E1 is tosses. Can anyone tell me, okay, can anyone tell me the description for E1 and E2? Tosses we need for head or tail, because we are looking for either head or tail. If we already have head in my hand, we already let me write. I already have head in my hand. Okay. And what about E2? Ekta and Akash is asking that why E1 and E2 are not same. When I said they are not same, I do not know, right? I mean, they could be same. We will be just calculating it. Let's just see if they are same or not. Okay. We will be calculating and we will check whether they are same. If they are same, then we will be getting E1 and E2 are the same answer. If they are not same, then we will not getting same answer. Let's just check if they are same or not. Okay. Sorry. 1 second. Yeah. So let me write E2 description also. Can you tell me what is the description of E2? So E2 will be, let me write it here. E2 will be tosses we need for head or tail, because that's my final goal. If I already have tail in my hand, this is the description for E2. Okay? Yes. Now let's just calculate this E1 and E2. So let me go to the next page probably, and let me calculate this E1 and E2. I hope the question is clear to everyone and the process is getting clear that we want to calculate this E1 and E2. I just assume that, okay, let's suppose this is E1 and this is E2. Which means, let me just calculate E1. So I will say, I already have head in my hand. And now I'm looking for head or tail. Now either head can come or tail can come. Now tell me, what is the number of expected trials that I made, or number of processes that I made till this point? Just one, right? Just one. These are not two. I'm not counting from starting. I already have that starting point is different. I already have a one head in my hand. Okay. This is just one. Everyone agree with this? Now, what are the number of tosses that I need for head or tail in this case? See, I got tail in my hand and now I'm looking for something else. So this is 1 plus something, right? 1 plus something. Now, can you tell me what is that something? This cannot be even. Reason being is that this cannot be again recursive. That's the problem. Reason being is that you are looking for head and tail, but you have already have tail in your hand, not head in your hand. You have tail in your hand and you are looking for head or tail. Then what it should be? Yes, Devananjan is right that it should be 1 plus E2. See, reason being is that one is one. I hope one is clear to everyone that why we are having one, because let's not worry about this particular problem. Okay, this particular problem is, let's suppose this is different. Let's not worry about this particular problem. Let's just focus on this problem that I want to calculate even, where the starting point is that you already have a head in your hand, and then if you're looking for head at just one toss, if you're looking for header or tail or whatever, okay, then you got tail, and then let's suppose you're looking for head at tail, but you got head till this point. So you made some partial progress, and then you will say that you already have tail in your hand, and then you are looking for head at tail. Basically, it will be 1 plus E2. I hope everyone is getting, but let me just complete the explanation, and then if there is any doubt, please tell me. Now let me calculate the E2. E2 means you have tail in your hand. Now either head can come or tail can come. Now you were looking for head or tail, and since head can come, that's why you will not say that you can stop here, but you can stop here. I mean, there is just one toss that you need till this point, right? So there is just one toss that you need in this case. But in this case, how many tosses you will be needing? You will be needing 1 plus something. One is already done, but you have head in your hand, and now you're looking for something, which is header or tail. So if you have head in your hand, and if you're looking for header and tail, header or tail, then you will be needing even number of tosses. Okay, so I got this E1 and E2 diagram separately. I got E diagram separately. So there are 3 diagrams, but let me just sum this up. So for E1, you will be getting this equation. Can you write the equation for E1? E1 will be 1 by 2 into 1 plus 1 by 2 into 1 plus E2. ठीक है, ये समझ में आ रहा है? See, this E1 will be 1 by 2 into this 1, because the probability is 1, probability is 1 by 2, and then 1 by 2 into 1 plus E2. Then can you write the equation for E2? This is almost same, 1 by 2 into 1 plus 1 by 2 into 1 plus E1. Now from these two equations, can you calculate E1 and E2? These are the two equations, two variables. I think this should be easy. So let me just go to the next page. This is E1 is equal to 1 by 2 into 1 plus 1 by 2 into 1 plus E1. This is E1 equation I got. This is E2 equation I got, which is 1 by 2 into 1 plus 1 by 2 into 1 plus, sorry, this is E2. Okay. So let's just calculate it. What you are getting? Can anyone tell me the answer? This equation is E1 equal to 1 by 2 plus 1 by 2 is 1 plus e by e2 by 2. This is e2 equal to 1 plus e1 by 2. And then you are getting 2. Okay. E1 and e2 as 2. So from these two equations, you are getting e1 equal to 2 and e2 is also 2. Yeah. So initially we guessed that because of symmetricity, both should be same, but ultimately we also put both should be same. Okay. I mean, if you are convinced here only that yes, both will be same e1 and e2 because this is symmetric, because this is head, this is tail, and either we are looking for head or tail. So head and tail are replaceable to each other, which means this is kind of symmetric case. So initially, if you're convinced, then you can just make e1 and e1 at both the places. This will just save your time. Okay, if you're convinced. Otherwise, if you're a little bit doubt, just make e1 e2, and ultimately we got two equations, and then finally we are able to solve for e1 e2. If let's suppose if I just write even in both the places, then from this just one of the equation I could have got it. Suppose if I write even in both the places, let's suppose here also I write even, which means here also I write even, then it will be even equal to 1 plus even by 2. And then if you solve it, then even will be just 2. Right? There is just one even and e2. Okay. So I hope everyone is getting it. Now I got even and e2, which is 2 and 2. So now can you just write this tree? This is this. Okay. Can you just write this even in place of the even? Can you just write 2? Can you just write 2 here? And then can you tell me what is the final answer you're getting? You are getting 1 by 2 into 3 plus 1 by 2 into 3. This is E, you know, which is 3. So E equal to 3 that you are getting. Okay. So final answer is 3. I mean, we will be solving with some other way also. We will be just checking that if we expand this tree further, then what's going to happen. But for now, let's just convince ourselves the final answer is 3. Reason being is that if you are tossing, then either head can come or tail can come. Then I'm probably suspecting that okay, I cannot stop here, I cannot restart here. So let's just make it even and e2. Okay, and then let's just calculate even and e2 separately, and then I will plug this later. So if I plug this later, then I'm getting this as an answer. So if I need to just get head, then I was getting 6. If you remember as an answer in the earlier question, I was getting 6. And for head or tail, I'm getting 3. I think this is also a bit justifiable that for head, if I'm getting 6, now if I just add some equivalent to it, which is head or tail, then I need, since I have more favorable cases basically, then I will be getting just half of this, which is 6 by 2, which is 3. Right? I mean, this is kind of, if you want to make some intuition, you can make. Otherwise, there is no problem. So let's just solve it with some other method. Okay, let me call it method 2. First, let me know if there is any doubt in the method 1. If everyone is clear or there is some, see, there might be some doubts, because reason being is that you are seeing this at the first time. So that's why there might be some doubts, but that's okay. I mean, you will be understanding this with more examples probably. Okay. So this is clear, right? Okay. So here, let me just expand this till maybe infinite. Okay. Let's just expand. Let's just see what's going to happen. So this is head, tail. Now you are going to get head, tail. Here you are going to get head, tail. This is where you will stop. This is 2. This is where you will stop, but you will not stop at these two places. So let's just see this head, tail, and then you might be stopping at this. You need to stop at this. And then let's just expand this. This is head, tail. This is head, tail. And then you need to stop at this. You need to stop at this, and so on and so forth. Right? We can keep on expanding. Do anyone want to try this particular method? I mean, just try with me, okay? So here, let me write number of tosses. And let me write with what probability. So 2 tosses you need with 1 by 2 into 1 by 2, 1 by 2 square into 2 probability, right? Because these are the 2 branches that are leading to 2. For 3 also, it is leading to 2, okay? For 3 number of choices are 3 into 1 by 2 square 2 power cube है ना, दो ही ब्रांच है राइट 3 की भी, ठीक है. For 4 also there is 2 branches only. Okay. For 4 also, sorry, for 3 also there are 2 branches. For 4 also there are 2 branches. Okay, I think this series will not be that tough. For 4, I think this is coming out to be easy series. So if you want to calculate the expectation, then let's just do it. So expectation will be, okay, so let's just do it. Expectation will be, you can just calculate from here. It will be 2 into, I think I can take 2 common. Okay, let me just take 2 common because it is common to all of the places. 2 common, let me just take. It is basically 2 into 1 by 2 square plus 3 into 1 by 2 cube plus 4 into 1 by 2 power 4, like this. Again, it is AGP. So what is the answer here? Let me just say this is S. So S equal to 2 into 1 by 2 square plus 3 into 1 by 2 cube, like this. And then this will be 1 by 2S will be 2 into 1 by 2 cube, like this, right? So it will be 2 into 1 by 2 square plus, if I just multiply by 1 by 2, 2 into 1 by 2 cube, hmm, 2 into 1 by 2 square plus it is 1 by 2 cube only. This should not be 2 into. Something is wrong. This is 2 into 1 by 2 square. There are 2 sequences that are leading to 1 by 2 square. Okay. 2 into 1 by 2 square plus 3 into 1 by 2 cube. Okay. And then if you multiply with 1 by 2s, it will be 2 into 1 by 2 cube plus 3 into 1 by 2 power 4, like this. This term is as it is. Why I'm getting 2 here? I don't know. Let's just solve it. Okay. This is 1 by 2s equal to, and then this is plus plus dot. And then if you just solve this is GP, you can say A upon 1 minus R. So this is 1 by 8 upon 1 minus 1 by 2, which is 1 by 2, which is basically 1 by 4, plus this is this extra term that I have, 1 by 4 plus 2 by 4, which is 3 by 4, and this is 1 by 2s, and then s will be just 3 by 2. Yeah, s is 3 by 2 we are getting. So inside this we are getting 3 by 2, and then if you multiply by 2, you will be getting 3. Okay, because s is 3 by 2. You can solve it, you are getting 3 by 2, and then if you multiply, you are getting 2. So you can solve in any way, whatever way you want. I hope that if this method is clear, where you can just identify, okay, let's just solve it for E1 and E2, and then you can solve for E1 E2. Okay, then it is better. Otherwise, in this case, actually, the infinite tree is also not a bad idea. If you're not getting anything, then just try drawing the infinite tree. Basically, with these questions, I want you to make understand that if you have any such of these patterns, then you should not be afraid of these kind of questions. Now you should be more comfortable that you can draw the tree till infinite tree, or you can stop to any level of whatever you want to do. You can play around it. Okay. So now let's solve this question. They're saying number of tosses until you get head tail. So we have solved for head. We have solved for head or tail. Now let's just solve for head tail. Okay, let's just solve for this. I don't know. Let's just solve for this for head tail. So if they're saying 6, okay, may not be. Let's just see. So initially we are having nothing. We are starting like this. Now tell me what we need to do. Anyone has any idea? With the short method. Not using the long method. Obviously, using the long method, you can definitely tell me, but using the short method. If you're looking for head tail, then what I should be writing here? This is, see, you will say one toss you already made plus something. One toss you already made plus something. Now you're looking for head tail, right? Okay, you're looking for head tail. Now here I think you can restart. Here you can restart, which is basically E, right? Since you can restart, it is restart. And here, this is 1 plus head tail. You're looking for tail, right? Okay, let me just assume that to be even. Okay. Basically, even is this, that you have head in your hand and then you are looking for, let me write the even description. We have head in hand and looking for head tail. Okay. Now head, either head can come or tail can come. Now tell me, if head comes, then what will be the progress that I have made? If tail comes, then what should be the case I'm having? Yeah, this is interesting. If head comes, then what I should be writing? If tail comes, then what I should be writing? Can anyone tell me? This is little interesting. See, if tail comes, then I have got the head tail, first of all. So I think if tail comes, then it is just a one toss. No, why you are writing E1, E2 like this? Why we need anything else? I should be stopping at this point, right? If tail comes, yeah, I should be, Devananjan is right. If tail comes, I will stop at this point right away because I'm looking for head tail. If head comes, then I will be basically in the original position. I have not made any progress with respect to this even. So I can restart with respect to even, which means I'm looking for head tail and I already have head in my hand, which means 1 plus even. Okay. So from here, you can get even, which is 1 by 2 into 1 plus even plus 1, which is 2 plus even. And then this is even equal to 1 plus even by 2. And then even you got as 2. Okay. Is everyone okay with this? Even is 2. Now, since even is 2, what you can do, you can just plug in this value and then you will get this. See, I said this, that head can come or tail can come. This is a start. I mean, you are not having anything in the hand. And then if head comes, then I said like, okay, this will be 1 plus even, and here it will be 1 plus E. That's what I said earlier. See, this is 1 plus even, this is 1 plus E, because I'm restarting with respect to my original process, right? So here this is restart with respect to original thing. That's why I'm having E. E means that I have nothing in my hand. I mean, this is just a pure restart. I have nothing in my hand and I'm looking for head tail. Okay. And why I have written even here? Because I have I have head in my hand. I'm looking for head tail, and which is same as even. So anyway, even is coming out to be 2. So this is 3, and this is 1 plus E. And then finally, you are getting E equal to 1 by 2 into 3 plus 1 plus E. I mean, this should be clear to everyone, but let me write in two separate terms, 1 by 2 into 1 plus E. So this is 3 plus 1, 4 by 2, which is 2 plus E by 2. So you're getting E equal to 2 plus E by 2. Finally, we will be getting E equal to 4. Okay. So if you're looking for head tail, then expected number of trials was 4. See, for head, how much you got? I think you got 6. For head tail or head, you got 3, I think. Here you're getting 4. Okay. See, the reason is that for head or tail, and for, let's suppose for head you are getting 6. It means for tail also you will getting 6, right? I mean, if you are getting head 6 for head, then obviously for tail also you will getting 6, which means you are saying that you need 6 tosses to for the head, or you need 6 tosses for the tail. Or if you're looking for one of them, maybe head or tail, then you just need 3 tosses. But if you're looking for a pattern which is which is basically differentiating, which means either head, tail, or tail head, which means either head, tail, or tail head. Then you will be needing 4. Now, uh, let's suppose that if I ask you that for head, tail, or tail head, how much you will be needing? What does your intuition says? For head, tail, or tail head? 2, right? Because it should be the half of this. Do you want to do attention homework, or should we do it now? For, let me just write it. For head, tail, or tail head. Okay, we need yeah, 4 is correct. Yes, this is correct. Okay. If you're looking for a different pattern, it is 4. If you're looking for same pattern, then maybe you need to work more hard, which means you need to get 6. I mean, you need to toss more number of times. If you're looking for bit different, if it is head tail is okay for you, then a bit lesser maybe, because you are relaxing your conditions, right? I mean, if you want the same thing, no, intuitively also it should be lesser. See, here I am saying that don't look at the with respect to the probability. Look at like this, that you want the same thing. Okay, you want the exact same thing 2 times. Then you need more effort. If you are okay with that with the pattern that head and then tail, or tail or the head, then you will be getting lesser thing. Okay. So, okay, Ekta, you can work with your calculation. You are saying that you tried with one tree diagram and you are getting 6. There must be something wrong. Okay. And you can send in the group. We will check. Okay. So you just do it as an homework that for head tail, or tail head, what you should be doing, or should we do here now? Suppose you start, either you get head or you get tail. Then you want head, tail, or tail head, right? Okay, let me call it as 1 plus E1. Let me call it 1 plus E2. Okay, you have head in the hand, and you can get head, you can get tail. So here it is 1, but here you just have head in the hand and you are looking for head, tail, or tail head. So what you should be writing here, this is E1. You have just one head in your hand and you're looking for head, tail, or tail head. Is this same as this E1 only? This is same as E1, right? It seems like same as E1. 1 plus E1 or 1 plus E2? I think 1 plus E1 only. You know? For E2 calculation, you can say you have tail in the hand and either head can come or tail can come. So if tail head, okay, this is just 1. Tail, okay, there is no progress, basically 1 plus E2. So if you just get the answer, I think E1 should be 2. We have solved these kind of patterns. I think we got E1 as 2, right? 3 plus 1, 4 by 2. Yeah, E1 is 2. So from here, you can get E1 is 2. Okay. And E2 is also 2. So this will be 3, this will be 3. And then final answer is 3. Oh, final answer you are getting 3, not 2. Okay. So 1 second. Okay, the final answer is coming out to be 3. Okay, it is not 2. It is coming out to be 3. Yeah, things are a bit counterintuitive, but if you work with the calculation, you can do it. So the final answer is coming out to be same as this. Okay. Anyway, like it is a bit counterintuitive because there we got 3. I mean 663. Here we are getting 443, which is same as this. So we need to actually think about it very clearly, that if you want to make some intuition out of it, but it is not worth, like for gate purpose, I think we are good. You can, as a student, you can just think about it, that why we are getting like this. Okay. Okay. So, so we are getting finally 3 as an answer. ठीक है, कोई प्रॉब्लम नहीं है. सी, बट द इम्पोर्टेंट थिंग इज दैट इट वाज अ कंप्लीटली न्यू प्रॉब्लम टू अस एंड वी वर एबल टू सॉल्व इट वेरी क्विकली, right? This is important because like in the exam they will not ask you these kind of questions, they will ask you something else if they ask, right? And if they ask something else, then you should be able to answer very quickly using these kind of pattern. Now you should not be afraid for the expectation if it is recursive expectation especially, right? Like if you are solving with those table thing, I mean if there is some question with the table thing, then obviously you should be able to do it. But if it is complicated, then they make recursive expectation recursive in the sense that expectation is expressed in terms of expectation itself. Then these kind of questions should also be clear. Okay. Okay.